Greetings once more, grade 11th. For this lesson, we are going to look at percent purity. And this is when you are given a substance which is not pure, and they want you to calculate the percentage purity of that particular substance. So, they say that an excess of dilute sulfuric acid. Keep in mind that your dilute sulfuric acid is in excess, reacts with 8 grams of, now you have an impure aluminium. And they say that in the reaction which occurs, 6.72 cubic decimeters of dry oxygen gas is produced. So you have the volume of the product, which is one of the products, which is hydrogen. And they say that that much hydrogen is produced at standard temperature and pressure. And they ask you to calculate the percentage purity of the aluminium. So in this case, they mentioned 3 things. They mentioned the aluminium and they said that it is impure. And they also mentioned the sulfuric acid and they said it is in excess. Nothing is mentioned about aluminium sulfate, and they mentioned the volume of your hydrogen, which is produced at standard temperature and pressure. Remember, when we looked at limiting and excess reagents, we said that if you have a substance that is in excess, and even though you know the number of moles of that particular substance which is in excess, you don't use the number of moles to compare using the mole ratios or the coefficients. You try by all means to stay away from the excess reactant. And we said that even if you have an impure substance, just like with this aluminium, when you want to compare the number of moles, you also stay away from the impure substance. Why? Because you know that with your excess reactant and your impure substance, you find that some of the mass will work in the chemical reaction, some of the mass will not work in the chemical reaction. So in excess, you know that um, some of the substance, which is in excess, obviously, some of the substance will work in the chemical reaction, some will remain. Remember, we said excess reactants are those that are not going to be completely used up. So we cannot use the number of moles there. And with impure substances, we said that some of the mass, which is pure, will work in the chemical reaction. And the impure part or the impure substance that remains will not take part in the chemical reaction. I hope that makes sense. So excess reactants and impure substances, we do not actually use their number of moles to compare in the mole ratios or with the coefficients of the others to get their number of moles. It means that for this question, what is left is the volume there of your product, which is hydrogen. And this is what we're going to use to calculate the number of moles and therefore compare using the mole ratios before we could then get to calculating the percentage purity of the percentage purity of the aluminium. Let us get down to it. All right, so you know that you have 6.72 cubic decimeters of hydrogen that is produced at standard temperature and pressure. And you know that at standard temperature and pressure, molar volume equals to 22.4 cubic decimeters. So you know 2 things. You know the volume and you know the molar volume. It means you're going to use the formula number of moles of H2 equals to the volume of H2 and divided by the molar volume. So that's going to be 6.72 cubic decimeters divided by 22.4 cubic decimeters. Let us just use our calculator very quickly. 6.72 divided by 22.4 gives us 0.3. That means the number of moles of hydrogen is 0.3 moles. Now that we know the number of moles of hydrogen, we are then able to use this number of moles using the mole ratios. Remember, because we want to calculate the percentage purity of aluminium, then we're going to compare hydrogen with aluminium. Let me see. Aluminium is 2 hydrogen. Okay, the coefficient of aluminium there is 2 is 2. The coefficient of hydrogen is 3. We know the number of moles of hydrogen, which is 0.3 mole. And using the coefficients, we know that if we want the number of moles of aluminium having the number of moles of hydrogen, we are going to say the coefficient of aluminium, the one you want, divided by the coefficient of hydrogen, the one that you have. So it's going to be 2 over 3 multiplied by the number of moles that you have, which is 0.3. And using our calculator there, it is going to give us, let me see, 2 over 3 multiplied by 0.3 gives us 0.2. So we have 0.2 mole. That means that the number of moles of aluminium equals to 0.2 moles. Right, now because we know the number of moles that we actually expect of aluminium, what we expect to have if we had pure aluminium. So the number of moles of aluminium is 0.2 moles. Now that we know the number of moles of aluminium and using that we're able to get the molar mass, it means we're going to use the formula N equals 2 mass over molar mass. And we're able to get the mass equals 2 number of moles multiplied by the molar mass. Number of moles is 0.2 multiplied by the molar mass. I had already mentioned it here. We have 27. That is from the periodic table. 0.2 multiplied by 27. It gives us, let's check, 0.2 times 27 gives us 5.4. So the mass that we have is 5.4 grams. This is the mass of, let me just mention it there, show it the mass of aluminium. Right. And this is the pure mass that you actually expect to have based on the mole ratios, based on the balanced equation there. Right. Now that we have the pure mass of aluminium, we have the impure mass from the question there of aluminium, which is 8 grams. We are able to then find the percentage purity. Now we say percentage purity equals to the pure mass divided by the impure mass multiplied by 100. Remember, we're looking for percentages. What is the pure mass? It's 5.4 grams divided by the impure one from the question there is 8 grams multiplied by 100. Let us do it quickly. 5.4 divided by 8 multiplied by 100 gives us 67.5. 67.5%. So the percentage purity of the aluminium is 67.5%. That means that of the 8 grams, 67.5% of it is the pure aluminium, and the rest, let me check how much it is. 32.5% will then be of the impure substance or the impure part. It could be dirt, it could be anything else that has contaminated the aluminium or whatever. But we know that of the 8 grams, 67.5%, which constitutes 5.4 grams, is of your aluminium. I hope that this was very straightforward and it was helpful to you. Cheers.